Hi, my name is Bridget Sincavage, and I'll be talking about methane clathrates and their use in treatment of fracking wastewater. Methane clathrates are also called gas hydrates for the fact that they are natural gas molecules trapped in a cage of ice. They form under high pressure and low temperatures and are unstable when removed from the environment they form in, which causes issues in recovery, and I'll talk about that later on in my presentation. There is a problem of a worldwide water shortage that doesn't affect everyone everywhere, all the time, but affects some places in every part of the world. And yet, sometimes, water is not being used as one would expect in those places. For example, it seems like all the time we're hearing about droughts in California and Texas. And especially in Texas, a large portion of the water available is used for fracking, instead of things like human consumption or farming. And fracking uses a huge amount of water. For every 1 barrel of oil they can recover this way, they produce 10 barrels of wastewater. This wastewater is salty and has chemical impurities that make it unsafe for human use. One way to work around the water shortage would be to recover that wastewater, finding a feasible process to make it usable. Existing solutions for wastewater recovery are conventional distillation and reverse osmosis. Both of these processes are highly energy intensive, slow, and ineffective for large amounts of water. So, in an attempt to find a better solution, gas hydrate desalination was figured out. Gas hydrate desalination is producing natural gas clathrates in the wastewater, and most of those are methane. This causes the salt and other impurities to separate out from that, and then they can be easily removed. After that, the clathrates break down into carbon dioxide and water, perfectly safe byproducts. The only problem with this process is that it requires temperatures below the freezing point of water, 0 degrees Celsius, just to form that ice. And to reduce the temperature that much requires a lot of energy. The solution I will be talking about is an improvement over the old method of gas hydrate desalination. It was developed by Japanese scientists Yonku Sol and Jongho Cha with help from the United States Department of Energy's National Renewable Technology Laboratory. It was developed in Japan because Japan is one of those countries with next to no natural resources. And with the Fukushima nuclear disaster 6 years ago, Japan's even turning away from nuclear, which was their main source of power. This improved process of gas hydrate desalination can be done at or near room temperature, reducing that energy intensity. The way they do this is using cyclopentane and cyclohexane instead of methane, but it keeps the same process and the same products. It increases the efficiency of this process to 90% from 70%. But as with all technologies, there are some problems with implementation. This one starts with recovery of the clathrates. They form deep underwater and within the seafloor beneath it, which makes them really hard to get to. As I mentioned earlier, they are unstable when removed from the high pressure and low temperatures of the ocean floor. The rising ocean temperature melts the ice cage and releases the methane. Methane is an extremely potent greenhouse gas, 25 times worse than CO2, though it doesn't stay in the atmosphere for nearly as long, which is why the melting ice caps releasing methane is a problem. Also, from a monetary perspective, any lost methane is a loss in efficiency. There are environmental impacts in the ocean as well as atmospheric ones. Removing clathrates from the seafloor can cause underwater landslides, which can kill the plants living on the seafloor and starving the creatures that feed on them, and that impacts the whole food chain above it, as well as the actual mining of it can potentially drive away all the fish in the area. In summary, though it is currently the most efficient way to treat fracking wastewater, there are potentially disastrous environmental impacts associated with it. The United States, Japan, Canada, and India have been heavily researching them since they were discovered in the 1970s, but the recovery issues have not been solved yet. There needs to be more research into its scale-up potential, but on its own, methane clathrates won't be a commercial fuel source for at least 10 to 15 years. References, and I will post the link for the YouTube.